Okay, the second part of our lecture today, which is Introduction to Geology. We'll just start with it. In the first part, we reached studying the atmosphere. This was the last slide. Now we are going to start with the Earth crust. This figure is very important because, as we said, that the main layers of the Earth are the crust, the mantle, the core. So now let's see what is the crust, the mantle, and the core. This is the core. From inside, this is the center of the Earth. So this is the core. It consists of two layers. One of it is liquid, one of it, and the core, the main core, is solid. So we have the core, which is divided into two layers. An upper layer, which is molten, it is liquid state, and the lower layer is in solid state. And without saying, when I say that the core of the Earth, it means very, very, very high temperature. The opposite is the crust on top. You may have places the degree temperature is 0 degrees or minus. So below here, the temperature may reach from 5,000 to 7,000 degrees centigrade, which is approximately the degree of the sun, temperature of the sun. So we have here the core. This is the first internal layer. On top of it, we have the mantle. The mantle is also divided into upper mantle and lower mantle. And we have the crust, which is on top. So now we are going to study the crust. The crust is what we live on, composed of cool rocks. Of course, I added the word cool because it is very important that this, you may be asked, what is the coolest layer of the, not cool, very good, it means cool in temperature. So the coolest layer, it is the crust, of course. So, so this is composed of cool rock, mostly made up of light silicates. The composition of of each layer is also important. For any layer, there are some knowledge that we need to know: the temperature, the density, the temperature, the density, and the composition, what it is made of. So for the crust, it is cool. This is the temperature. It is made of silicates, made from silicon. Silicates is from silicon. And it is light. When I say light, it means that the density is very low density. So these are the three important things. Last thing is the thickness, approximate thickness. It varies, as I said, from one reference to the other. Also, what is important, is it solid in a solid state or in a liquid state? For the Earth crust, is it solid or liquid? It is solid, but all of it is solid? Water. So it is solid or liquid. Both are. When I say it is solid, it means that it is fully solid itself. When I say it is liquid, it means that it is all liquid. But the crust itself is partly solid and partly liquid. The thickness of it, from 5 to 70 kilometers. You may find in other places, they say from 5 to 35 to 45. Don't worry. All of them are correct because we don't know where it was measured. If I measure at this location, it's different from another location. So the thickness, it varies from, say, from 5 to 70 kilometer. It is at a minimum thickness at oceanic crust and maximum thickness at continental crust. Do you know what's the meaning of oceanic crust and continental crust? The crust is like a plate. This plate, what does it carry? Does it carry water on top of it? If it carries the oceans, then it is called oceanic crust. So it is the crust that on top of it we have the oceans. Of course, if I have a crust and on top of it is the ocean, by logic, it will be a minimum thickness. But if I have the crust that carries on top of it Mount Everest, it should be the thickness will be the total of Mount Everest plus whatever small thickness below. So the thickness is about 5 kilometers. Number 5 is very important because obviously it is the minimum that they would accept for a thickness of a layer. All reference book use this number, 5 kilometers. So 5 kilometer is the thickness at the minimum, it's the minimum thickness at the oceanic crust. The maximum continental, which means at the locations of the mountains, it's between 30 to 40 kilometers. The thickness of when I say the thickness is of the full crust between 5 to 70, it means that at some very high mountains it may reach this 70. So this is the crust. Before we go from the crust to the mantle, this is the crust, and below it is the mantle. There are few layers that we need to describe because if I do not say it now, you will lose the layering. What do we call? It's a layer by layer, so we have to say it now, though it is not. As I say, it's the crust, then the mantle. But before I go to the mantle, let's discuss these few layers. If I say it now, you will understand it better. We have something called the biosphere. Bio comes from biology. So biosphere, the regions of the surface and the atmosphere of the Earth or another planet occupied by living organisms. So biosphere means wherever living organisms are found. So where are living organisms found? Yes, but where? Just we have to specify locations. Living organisms, we are living organisms. We are on top of the crust. There are plants and roots of the plants going into the ground. So the ground have living organisms. Water has living organisms. So that's why when we say, look at this, this location of where I'm pointing, this is the biosphere. So the biosphere points at the top portion of the crust plus maybe some of the atmosphere, because in the atmosphere you find birds, you find living organisms within the atmosphere. But of course, we don't have living organisms above the ozone layer. Why don't we have living organisms above the ozone layer? No, above the ozone layer there is still atmosphere. There is still atmosphere, but the conditions are not suitable for living, because we said that the ozone layer protects us to live. Otherwise, we would be burned by the radiation. So if I go outside the ozone layer, then any living organisms there will have problems in living. I cannot say that there is no, I don't have this information, but I say that I don't expect to find living organisms above this ozone layer. So biosphere, it is not just one layer. It is a combination of parts of layer. It takes from the crust and it takes from the atmosphere. Okay, so that's why I put it on top. Then we have something called the hydrosphere. From the name hydro, what does hydro means? Water. So it means the part of the earth that has water. Where can we find water? Oceans, rivers, and we have it in the atmosphere also. We have clouds. Clouds are water. So hydrosphere and biosphere, they may be more or less at the same location, but I am describing them from different perspectives. One is describing the living organism, one is describing the existence of water. So they may be at the same location. One of them may be upper or lower, it's not important, but they share the same, approximately the same location. But here I am looking for something, and there I'm looking for something else. So hydrosphere, all the waters on the Earth's surface, such as lakes and seas, and sometimes including water over the Earth's surface, such as clouds. So this is the biosphere, the hydrosphere. The third layer is called the lithosphere. Of course, I don't know Greek, but obviously litho has something related to rocks. So lithosphere is the rocky outer part of the Earth. So here I am just concentrating on whatever having rocks. It is made up of the brittle crusts and the top part of the upper mantle. Did we study mantle? No, we did not say anything about mantle. Mantle is the next layer that we are going to study. But here, that's why I put the lithosphere as the bottom layer I'm describing, because it has part of the crust and part of the next layer that we are going to study. So the lithosphere is the coolest and most rigid part of Earth. Of course, the lithosphere contains the crust. That's why we can say that the crust is the coolest part, and we can say that the lithosphere, of course, is the coolest part because it contains the crust plus part of the next layer, which is the upper mantle. Okay? I try not to confuse you by different terminologies, because you may find somebody saying that the crust is the coolest place and somebody else saying that lithosphere is the coolest place. Yes, they are both. Somebody saying that the biosphere is located at this location and the hydrosphere is located at the same location. How come? Because we are looking at this place from different perspectives. One from the biology perspective and the other from the hydrology perspective. Of course, again, it is thinnest at mid-ocean ridges, of course, because we said that the crust is thin at mid-ocean. So if I add this to part of the mantle, it will still be the thinnest part. If I try to compare the lithosphere, where is the thinnest part of the lithosphere? It will be below the oceans. Okay. Where tectonic plates are tearing apart, he's just describing what is the lithosphere. Is that the lithosphere is the layer where tectonic plates, tectonic means it deals with something like earthquake, the movement of the plates. Movement of the plates is tectonic. We will have a lecture for tectonics. But where is this tectonic action is happening? It is happening in the lithosphere, because we said that the lithosphere is the rocky part. Of course, it will not happen in the hydrosphere. It's water. It's not happening in the biosphere. Biosphere is not concentrated on solids. It's concentrated on do I have tectonics in the clouds? I don't have tectonics in the clouds, so I cannot say that tectonics will happen except in the lithosphere. It is bounded by the atmosphere above and the azenosphere, which is below. So now it means that next we are going to study something called the azenosphere. Just when we come to it, but you need to know that now the lithosphere is the rocky part. It consists of the crust and part of the layer below it, which is part of the upper mantle. Let's just take a look at our Earth from above. Any place where you find water, it's called the hydrosphere. Any place where you find land, then it is the lithosphere. Okay. What does the lithosphere consist of? Because this will help us in next lectures. The lithosphere consists of three parts or three components: minerals, rocks, and soil. What is minerals? We said that minerals is the main components of rock. It is the main constituent of rock. It is minerals, naturally occurring inorganic substances. So minerals are inorganic. Do you know what is the difference between organic and inorganic? Oh, okay. So minerals are inorganic. It means that there are some inorganic material. Where does this inorganic material are found? What's the source of inorganic material? Waste, human beings, corpse, animals, corpse also. Anything, any living organism that decays, it changes into an organic substance. Even when it is living, it is an organic substance, but I cannot use it while it is living. When I'm using it, it means that it has already decayed years ago, maybe millions of years ago. So we have minerals, then we have rocks. Rocks are made up of several minerals. One type of rock may consist of many minerals bound together. Plus, it may contain also organic substances. So rocks are minerals, maybe plus organic substances. What about soil? Soil is the result of the degeneration of rock, or the decomposition of rock, or whatever you call it, or the weathering. This is more appropriate. Weathering of rock. When rock weathers, it changes into soil. Not all of rock, of course, but say sedimentary rocks. Sedimentary rocks, it changes into soil. By the way, when we come to it, you will find that when rock weathers, it changes into soil. And when soil consolidates, it changes again into rock. So we have something called the rock cycle. The rock weathers to change to soil, then the soil consolidates or get closer together under pressure and changes again to rock, and so on. The cycle continues. So soil, what is soil? Soil is a mixture of decomposed organic matter and disintegrated rocks and minerals. So this is the contents of this portion, which is the lithosphere. The hydrosphere is water, and you all know the composition of water and what it may contain. So again, we come back to our figure here. Just to remind you where we were standing. On top here we have the atmosphere. Here is the crust, and this crust is part of three layers. It is part of the lithosphere, because as we said that the lithosphere is the rocky part of the soil, of the earth, which is the crust plus part of the upper mantle. Here you find it is written here mantle, and here it is core. So we have core, mantle, and then crust on top. The lithosphere is really part of the crust is here on top, and this lower part is part of the upper mantle. So this is the lithosphere. The hydrosphere is everything related to water. So this is the hydrosphere, the seas. The biosphere, as we said, everything related to biology, anything that includes living organism. So it is also within the crust. Maybe you may find something in the upper mantle, who knows, but anyway, it is the top portion plus some from the atmosphere. So the mantle, which is the layer that we are going to study now, is the layer following what? The crust. This is very good. The layer following the crust. It is divided into two parts, upper mantle and lower mantle. The upper mantle, see here how many terminologies we have to memorize. Upper mantle is called the asthenosphere. Lower mantle is called the mesosphere. So, by the way, we said the asthenosphere before. This is this is the asthenosphere. We said that the lithosphere is the crust plus part of the upper mantle, or the asthenosphere. They are both the same. Okay. So now we have to study each alone. What is the upper mantle, which is the asthenosphere, and the lower mantle? We'll go back to our figure here. The asthenosphere is the upper mantle. But just before we go to the asthenosphere, just I remind you that the mantle, we said here, it is still hot. So the asthenosphere, once we reach the mantle, this is very hot for us. Nobody can drill and reach the mantle. This is the maximum people managed to drill was something like 1.3 kilometers. But here we are speaking about many kilometers below ground. So nobody reached the mantle by drilling, because it is very, very hot for us as a human beings, or for our equipments. We cannot send anything to drill. So far, we cannot send anything to drill and reach this layer. So we can say it is still hot. Of course, it is still hot if we are describing starting from the core, because we are going to say that the core is very hot, the mantle, the lower mantle is very hot, and the upper mantle is still hot. Okay? And then once we leave the mantle and go into the crust, we say that we reached a cool layer. Cool means that we can endure. It may be very hot for us, but we can still live, or not us. There may be organisms that can live there. The mantle, the total thickness of it, this is also a little bit fixed in most references. It is 2,900 kilometers. So 2,900 kilometers is the thickness of the upper and lower mantle together. The upper mantle, the asthenosphere, the thickness of it is 200 kilometer. So the rest for the lower mantle will be something like 2,700. I mean that the upper mantle is not very thick compared to the lower mantle. So the upper mantle, it is below the lithosphere, or we can say better that it is below the crust. The upper mantle is just below the crust. Why? Because the lithosphere, as we said, may take part of the upper mantle, may take part of the upper. That's why I tell you in geology, if you look at one reference and the other, we don't have lines of separation fixed. People may say that the lithosphere ends up in the crust, or the upper mantle starts after the lithosphere or start after the crust, but in general, we know what they mean. So it is below the lithosphere. For me, I would say, I would modify it and put it better, say below the crust, in which there is a relatively low resistance to plastic flow. This is very, very important to know that within the asthenosphere, we have plastic flow. What is plastic? Plastic means that it is not elastic. Elastic means if I put a load and I remove the load, everything returns back to normal. If I have a sponge, I compress it, and then I remove my hand, the sponge will return back to its original shape. So it is purely elastic. But clay, if I have a piece of wet clay and I compress it, and then I remove my hand, I will find my finger, my hand print on it. So it is plastic. Whatever deformations that happened did not return back to original. So here, when we say plastic flow, it means that the layers within this upper mantle can flow. It can move. Any layer can move from one place to the other. Can rock move? Yes. We may see some photos. I think I have it here, showing you that this can happen, but I don't know. Anyway, I don't remember where I put the photos, but it will appear somewhere in the next lectures. Anyway, it means that there may be flow. We can go back to this. You see here? What is written here? Convection currents. It means that within this solid part, there may be flow. Hot layers from below will come up, and once it cools, it goes down again. Maybe this is one good way for cooling the earth. Suppose you have a kettle or anything you put on the stove, and you put it on fire. What will happen? It will, at the beginning, it's not hot, but maybe after 1 hour, all of it will be hot. So why the internal, the core of the earth is very, very hot? It is 7,000 degrees centigrade, and we are still having ice on top of the crust. There should be a cooling way. How this happens? Maybe the mantle would do this. The hot layers go up, and then it cools and it goes down again. So this is called convection current. So if I tell you where is the convection currents happening, it is happening in the upper mantle. So I'm just giving you what is the important features of each layer. So the asthenosphere, we said below the crust, in which there is relatively low resistance to plastic flow, and convection is thought to occur. This is the convection is thought to occur at this location, and this is very important. Mostly made up of metallic silicates and sulfides. So it is made, the more we go deeper, the more we have minerals of high density. We said at the top it is light silicates. When we go down, it is metallic silicates and sulfides. It means that we are now going to deeper layer with higher density. The thickness of it is about 200 kilometer. It means that the asthenosphere is very thin, which is the upper mantle, compared to the lower mantle, which is the mesosphere. The mesosphere will be the remaining part of the 2,900 kilometer. So the mesosphere, which is the lower mantle, here is the mantle. This is the asthenosphere. The mesosphere is the lower mantle, which is this portion. We can say here that it represents approximately 56% of the Earth's total volume. It's very huge, and is the region from 660 to 2,900 kilometer below ground surface. Anyway, we said that the thickness of it, just subtract 2,900 from 200, it means 2,700. It's an approximate thickness. Below the asthenosphere and the outer core. So now we finish the mantle. We go to the last layer, the last main layer. The last main layer is divided into two sub-layers. So the last layer from inside is the core. Core is the Earth's core is very hot, very dense center of our planet. So it is very hot, very dense. The ball-shaped core lies beneath the cool, brittle crust. So it is below the crust and the mostly solid mantle. So the core, then the solid mantle, then the crust. Why do we say solid mantle? You will know now, because when we are going to speak about the core, you will find that there is a layer that is completely liquid. Radius of about, so we have the total radius of the core is about 3,500. It consists of outer core and inner core. Luckily, outer and inner core do not have other names. It is outer core and inner core. We don't have to memorize another name. So the outer core, hot, very hot, but less than the inner core, of course. When we are speaking about the temperature of the outer core, it is 4,000 to 5,000. When we are speaking about the inner core, it's from 5,000 to 7,000, and this is approximately the heat or the degree of the temperature of the sun. It is composed of nickel and iron. So the outer and the inner core are composed of nickel and iron, but one of them is solid and one of them is liquid. Here, you see, this is the core. The outer is liquid, the inner is solid. They are both of the same material, but the outer is solid. It is in a molten state. Just to remember the constituents of the core, we know nickel, Ni, iron, Fe. So it's N-I-F-E, knife. So knife is the constituents of the inner and outer core. One of them is solid, one of them is liquid. Okay, we now finished, luckily, all what we need to memorize about the the layers of the Earth. We go into some subjects that will help us later in understanding next chapters. There is something called P wave, and there is something called S wave. P means primary wave, S means secondary wave. Some people say P pressure wave, S shear wave. They are both the same, because primary wave are mainly depend on pressure, secondary wave mainly depend on shear, so they both can work. So P wave and S wave, this is the velocity relative to depth. This is the P wave. If you look at the P wave, you will find that here the top part is the mantle, then followed by the outer core, followed by the inner core. By the way, you will find here CMB. CMB means core mantle borderline. This is the interface between the core and the mantle. Above here, it is crust mantle. Crust mantle. No, it's not crust. Also, it should be core mantle. Core mantle. Yes, because the below is the core and the above is the mantle. So it is core mantle borderline. What is important in this figure is that the P wave is higher in velocity. The S wave is lower in velocity. It means that if I have a source of energy, and like an earthquake, and I try to measure, to find if I have like the earthquake of today, the seismographs, which is the equipment that measures the oscillation of the earthquake. If I normally it is not moving, it's in place. Once an earthquake starts to shake the ground, these equipment start to shake, and once they shake, they record the start of an earthquake. So I expect to measure the P wave earlier than the S wave. This is just for people who are dealing with this. Once they start, they will find that the earthquake, the movement is a little bit not high, because they are recording only the P wave. It came very quickly from the source of the earthquake. Then later the S wave came along. Once it came along, so it started recording both the P wave and the S wave, and the oscillation increases. Anyway, this is what they do in measuring earthquake. So what is important, that the P wave the velocity is higher. What is another important thing is that the S wave do not penetrate in liquid. So it ended at the CMB. It did not penetrate because it is called shear wave. Water does not have any shear resistance. So the shear wave or the secondary wave will stop here. This is another graph for the velocity and the depth, but this is for the temperature. If this is the temperature, then the highest temperature will be inner core, and it reaches till it 0 or maybe below 0 on top. This is what we were saying about the S wave and the P wave. If I have an earthquake here, and I'm recording the earthquake at this point, then the S wave will come to me. But before the S wave come, I have here a P wave which is faster. So if I'm standing here, the black thing is the P wave. So the P wave will come to me first, and I will start recording it. And after recording it, I will find that the P wave is coming. Suppose I'm standing here. What will happen? What will happen is that I will record the P wave, but the S wave will not come, because to come to me, it had to penetrate a liquid area. So they are not going to record it. I'm just giving you information so that people who record these know exactly what to record, and when they record, they know that it means that if they record something only with the S wave, and I mean with the P wave, it means that the waves coming, the P waves coming to them were lost during passing through the liquid core. Anyway, this is for information. The last thing we need to know also for info, this is important for our general knowledge, is something called the inclination and the declination. If I have, do you remember, do you know something called geographic north and true north? Anyway, if I have a compass and I put the compass on my desk, it will point to a direction. This direction is not the true north. If you look at the map, our north, say it is at the direction of the north of the sea, on top of Egypt, the north of Egypt. But if I put the compass, it will not take the geographic north, it will be deflected a little bit. Why is this deflection? Because the compass follows something called the magnetic field of the Earth. The magnetic field of the Earth is not matching with the true north. It has something called the inclination angle. So first we have something called the inclination angle, and this is fixed everywhere on Earth. If you measure the north in any place, it will be shifted by an angle. This angle is 11.5. 11.5 degrees is the variation between the true north and the geographic north. Why it is important? It is important for sailors. People going into the sea, they are following the compass. If they are following the compass, they will go 11.5 degree away from their target, so they have to correct this target. This is one thing. And the other thing is called the the first one was the declination angle. So the angle of declination is the angle between the true north and the magnetic north. The other thing is called the inclination angle. These are the lines of our magnetic field. The needle of the compass will point, of course, to the direction of the magnetic north, and it may not be horizontal. It may be inclined a little bit up or down. depending on what? Depending on the location on the Earth relative to the magnetic field. If I am at this location, the needle will point at a direction, say the tangent of the magnetic field. So this will be the shape of the needle to understand what's the difference between declination and inclination. The needle will be pointing downward, a little bit downward or a little bit upward, depending on its location. If the location is at here at the bottom part of the Earth, it will be pointing upward because the tangent here is pointing upward. If it is here on top, it will be pointing downward. So these two information, declination and inclination and true north and geographic north, are very important in defining where are the locations on the Earth. Of course, now everything is computerized and is electronic. You just open an equipment, it tells you everything, but these were the basis that helped people to design these equipments. This ends our introduction lecture for today. For next lecture, we are going to go deeper into tectonics to study it in details. Thank you. See you next week.